Hello viewers, welcome back to video tutorial on AgentGrid. In this series of video tutorials, we were explaining different patterns of agent with the help of our open source AgentGrid SDK. So before coming to this video, I request users to go and watch our previous videos. So what all different patterns we have covered in previous video, I'm just going to show here. So in the agent, we have three folders here. One is agent codes, agent guides, and agent registration. Agent code is where all the codes are present that are used in this video tutorial, along with the SDKs and libraries of agent SDK. And agent guide is about Jupyter notebook, and agent registration is for registering the agents. As soon as you build a dockers or a docker containers, you need to have a registration done before deploying those dockers. So all the registration related things are here, and also how to run the how to build the containers, how to deploy the containers, how to run the inferences. All those details are present in the agent registration folder. So before getting into our latest hierarchical pattern, we have covered several other videos in our previous video. Like first one is a sequential pattern, conditional sequence pattern, parallel pattern, router pattern, orchestrator agentic pattern, human in loop agentic pattern, critic reflection pattern. And in this video, we'll talk about a hierarchical pattern. So yeah, the tutorial is about a hierarchical agent pattern with open source AgentGrid SDK. So whenever we were explaining pattern, we were taking certain examples to explain the pattern. So in current scenario, we'll be using a software company, a software company as an example, where different agents and sub agents will talk to each other to create a product. So hierarchical agentic company demo using AgentGrid SDK, and we focus on a software product lifecycle, where we have a CEO who will generally kick in idea, and then it will be given to the chief of staff, a coordinator mainly, especially a coordinator who talks to specialized teams. Like we have a marketing team, financial team, architecture team, development team, and testing team. So this chief of staff or COS will basically coordinate to all the specialized teams, and those teams will have their own sub agents. So at the end, all the sub agents will coordinated by their team lead, and team lead will talk to the chief of staff. So this coordination will continue to build a final project report or a final project. So to know more about AgentGrid, you can click on the links here. So it will take you to the GitHubs and documentation pages. And to know the more on agentic patterns or a video or a blog, you can click on the link present here. So this I'll not explain, as I have already explained in the previous videos. I request you to go and check out the previous video and then come back and check this video. So hierarchical pattern. So this basically mirrors a real world enterprise structure. So in this video, the software company demo, it just tried to mirror a real world enterprise structure. It handles a complexity by delegating tasks down chain of command and routing the technical artifacts between the specialized department. So we have a initiation done by the CEO agent. So CEO will get an idea. So that idea again will be given by the user here. So user will send the information to CEO agent. CEO agent will kick in the operation by sending to chief of staff. So CEO will basically refine the user project into a structured problem statement and gives it to the chief of staff. And then chief of staff identifies necessary team required by the for this project, and then it kicks in the budget estimate, because for any given project we have to estimate the budget. So we have different teams. We have a testing team, a development team, and architecture team, marketing department, and a financial department. So under those different agents department, we have again sub agents who are specialized, or they are doing a specific task. So let's say a testing team has a testing agent where only one sub agent is present, whereas in the developer there is an front end agent and a back end agent. So by the name you can understand that they are responsible for generating codes related to front end and back end. And we have an architecture team where there is a senior architect and junior architect. And one thing is, we are using like whatever so far we have learned the 7 patterns, right? So certain patterns we'll be using it here. let's say for this architecture pattern, we have a senior architect and junior architect, where junior architect can propose something, and then it goes to senior architect. Senior architect can refine. So it is basically a critic reflection pattern we are using here. Next is a marketing agent, and where you have a delegation task, like marketing agent will team lead will delegate the task to individual agents like content agent, planning agent, strategy agent, and visual agent. So where they are responsible for individual task, and then they will give it to the aggregate that content to marketing team lead, and marketing team lead will aggregate all the output of these agents and send it back to chief of staff. So it's basically like a the aggregations, like a third pattern, parallel pattern. You send the input to all the four agents parallelly and collect it, and finally you give it a response. So here we have a financial team, where coordination will happen. Basically, financial team will make a routing decision as well. First, it will talk to the accounting agent, gets the data. Like accounting agent is basically, it will maintain a book of records, like how much money is there, how much budget is there, and whenever there is a transaction, it will maintain it. So basically, financial team will coordinate the with the accounting team. Accounting team provides how much budget we have, and with that detail, it will try to talk to the controller agent and strategist agent, where whether this project can be approved or not. So these agents will provide the suitable feedback based on their the specific nature of those agents, and with those feedback, the financial team lead will take a final conclusion whether to accept this project or not. So if project is accepted, right, so it will directly go to the chief of staff, and chief of staff will directly send the task to these agents. If the budget is not approved, so if it's not approved because of budget constraint, so then the financial team can maybe do some slashing of a budget or something like that to some teams. So initially, as soon as the task comes to agent, CO agent, it will send it on to chief of staff, and then chief of staff will send it to all the four agents, because they will do real work: marketing team, architecture team, development team, and testing team. It will ask them for a budget estimation, and the team lead will try to estimate the budget like based on the task given to it. They will try to give an rough approximation of the budget, and this chief of staff will collect all the budget estimations and then sends it to the financial team. Financial team will take accounting agent help, and controller and strategist feedbacks are received, and then it aggregates, and then it try to say whether go or not. So based on this, it will come back to the chief of staff, and if project is approved because of the finance, then it will go to it will ask a task to be executed by these individual agents. So we have a testing agent, developer agent, architecture agent, and marketing agent. So for all this agent, the chief of staff will send hey, you can start executing, because budget is approved, you can start executing. So now the individual agent will execute their task. Let's say marketing team can work independently of these agents. So as soon as it get approvals, it will prepare, like it knows what is the use case, and it prepares the content to be published, what content, what all content we need to produce, so that we can have a good publications or a blog or kind of thing. And a planning agent went to what to how to plan, or strategist when to release. All those kind of a planning and strategy thing will happen in these two agents, and whom to who is the target audience. So all those things will be taken care by the planning agent. And strategist is like how to plan, like first week of this project life cycle, what we need to do, second week, third week. So that way it will try to do a strategy for a release cycle. And visual agent is about a visual generation. Basically, we'll use a Google Gemini on Nano Banana, so for a image generation. So this will basically generate some agents. So right now we are restricted like just to generate 3 agents, and so this way it will give all the marketing related materials, and this will collect it, and it will give it to the chief of staff. So in between, since all this has gone to the other agents as well, other agents also will be doing their work in parallel. Now architecture agent, before developer agent and testing team, architecture has to create some ground architecture. So there we have senior architect and junior architect, where they will use a critic reflection pattern to communicate within each other. So this will generate a basic architecture. Then senior architecture will put a critic on this, like why can't we do this, or some other issues, how will you resolve it. So that kind of a question trigger will happen. Again, they will talk to each other to resolve the architecture. So right now we have restricted to like three set of 3 rounds. So after 3 rounds, they will find this senior architect will finalize the architecture and will pass it on to the team lead, and then team lead will pass this information to chief of staff, and then chief of staff will give the architecture details to developer team and testing team, and testing team will start implementing the based on the architecture, right? It will start a plan like what all we need to do a testing, because it has a architectural details. But final further tuning can happen based on the developer team lead as well. So once developer team lead generates, we have a front end and back end sub agents. So they are responsible for breaking down the task and generate their component, like what are the front end required, back end required. So once they generate their files, they will provide it to developer team lead, and developer team lead will give to chief of staff, as well as it will pass on that information to testing team. So testing team, based on the developer team's code bases, it will try to plan a testing plan, like what all need to be tested. If it's a UI, what all need to be tested. If it's a backend, what all need to be tested. So that kind of a testing plan will be implemented. But right now, we are not going ahead by deploying that app and test it. So that way we are not going to a complex part. So right now we are just giving an idea. The testing team is also available, which will be coming under chief of staff for mainly, especially for a testing of the development task. That feedback basically can go on, meaning testing team can identify some bugs, it can provide it to a developer team again goes back to again front end or back end related to the bug, and they can again further fine tune it, and again it comes back as a new release. Then it can go to the testing team, again they will be doing a testing. So this kind of a loop also is possible, but we are not gone to that extent to in this demo. So we have different agents here. CEO agent, they are CEO agent and chief of staff agent, they act like a main leadership. These are the two files, agent COI.py and agent COS.py. And we have a marketing team where we have one team lead. Under them, under the team lead, we have content planning agent, strategy agent, and visual agent. And we have a financial team where one team lead is present and 3 sub agents are present. Architecture team, we have one team lead and senior and junior architecture. We have a developer, we have a team lead, front end and back end, and we have a testing team where team lead is present and testing dev is present. So let me just show you some codes. They are like if you have seen our earlier videos, they will look almost similar, so there is no changes in it. So let me just show you the agent co.py. So in the top you will generally see the signatures, as we are using a DSPy for our agentic task. So you will find a DSPy signatures, and whatever is present in this comment, they are the system messages for the LLM. And this basically CO signature takes raw ID as an input, and it will give the problem statement as an output. Along with that, it can provide basically it will provide a JSON as output, and it has a product idea priority, whether it has to be a cheap product, fast product, or premium product. It will decide, or we can also send it as an input from the user side, whether it has to be a cheap product, fast product, premium product. That also can be sent. So next we have a CEO model, which is responsible for doing an inference using a chain of thought, and it uses the signature that we have defined here. So it is using the DSPy chain of thought. And payload processor, it's for just basically breaking the inputs and inputs. So we have two classes here, agent task and agent result. Agent result is what has to be returned from this file, and agent task is what it will this main code will receive. So they are the inputs and outputs structure. So basically from that input we are breaking down like raw idea, what are communication types, model name, session ID, such kind of details we will break it. And this kind of payload will be available in all the agents, but they also might have a different content here, like based on the agent. Let's say, let me just show you here. Okay, this may not have it, but if any other code has this payload processor, so they might have a different inputs, because the input is coming in a different way for each and every sub agents and agents. So their what they break down will also be different. So this will remain same. Model context manager, basically this will provide a context to the DSPy for doing the inference. And we have a special class here, AIOS DSPy LLMs, and this class right now can handle inferencing via AI, the model that is deployed in AI voice, the LLM model that is deployed in AI voice, as well as the models that are present as a third party like Gemini or OpenAI model. So if you have any other vendors, so then we just have to put an if and else condition to handle those vendors. So this will provide a context. So how to set a context? So you can do this dspy.settings.context, and you need to just provide an LM, and that LLM is provided from this particular class. If you give the get chosen model, you have to pass the model name and session ID. So that model will return an LLM object, and that object is what used by dspy settings. So this is the main class CO agent, where we have an init function and we have a on preprocess function and a on data function, other function, and one more is a get muxer function. So this function will be used wherever we want to do a muxing of a kind of operation. Right now we don't have any mux kind of operation, so that's why I have not used a muxer for this particular agent. So we have a subject and context. Subject is basically I was explaining about a registration. So whenever we register an agent, so it is a JSON that we need to register. So we are providing a lot of details related to the agent. So what happens is this: once this contents are registered, it's basically available in the DB, and anyone can query it. So that if you want to know what this agent is, its capabilities, what is any other metadata, right? So you can basically query it. So that's why we wanted a registration files. This is the registration JSON file. So all the metadata related to registration, right, of that agent is available in the subject. And context is basically a object that passes from to your code and from the AI voice AgentGrid. So it has a lot of special functions and objects, so which are useful for certain of our activity here. So whenever it is required, I'll explain. So you can check our previous videos for this, what all we are using with the self.context. So default message if available, right, you can, if in the registration file, since you are targeting, you are pointing to self.subject, so it is definitely from the registration file. So you can in the registration file you have a subject persona default system message. So you can go to persona class and there is a default message. So that's what we are trying to access it here. So right now this agent CEO is not having any default message. So definitely the default message is not from the registration, but we are using it from the doc string here. So if you have several signatures, like I'll explain one other agent COS, it might have several signatures. So that's why there is no use of the default message, because it might be doing multiple activities. So either you can take the default message or system message from the registration file, or else directly in the doc string. So these are other like AISPDL, DLM object module, payload processor, model context. So, and we have one special variable known as task registry, which you don't have been there in the previous videos. So this will basically maintain all the input and output of this particular agent in this particular variable, so that it can access anytime. Again, this HIS modules, which is like human intervention system. So human interface system. So we are using it for passing on the outputs of any of these agents, right? We have several agents. So watching them in a dashboard is very difficult. So in the Docker logs is very difficult. So we are just creating one setup of using a Streamlit, where they will push all this any input or output coming out of this particular agent to a dashboard of this sort. So we have several agents here, like say you have a CEO team and chief of staff team, architecture team, finance team, marketing team, developer team, and testing team. So you can switch these tabs to get different agents content. So that I'll explain in later section. So we have a config, his client, and in the on preprocess is the first function that is called. It will be given with the input, and we need to pass that as an array of tasks, and then that will be called by the on data function. So in the on data, we are receiving an agent task that we need to break it down. So here some if and else conditions will be there, whether it's if it's a final outcome, because the final output can come from the COS, agent COS, or whether it is an first input. So if it is a final output, we are simply returning it to the user. If it is not first input, meaning like input is coming from the user, which is not a final project outcome, so that's why we are passing it on to the next task. So here we are dumping everything, every details that is wanted, the task registry with the task.task ID. Task ID should be where, like, you are creating a first project, right? So whenever you are creating one project, you can generate one task ID and you have to pass it on in the input in the user's request, and based on that task ID we are just maintaining a dictionary. So every time you create a new projects for this agent, like for agent CEO, so it will be whenever you are sending a new input request to this agent, it will be stored in the task.task ID variable in the task registry. So we are just storing user request and model name and session ID, and then we are doing an LLM inference. Basically LLM signature is executed here, and it will give the output, and from that output we are trying to extract the JSON contents, and then I am creating an problem statement class. So for that I am just passing on the extracted JSON, and that is the problem statement. And now that problem statement I am just passing it in a text field to the next agent. So next agent is our company chief of staff agent, and I am passing this particular JSON. So where we have task type equal to initiate text, what is the whole text of this particular output of this particular agent, and the user request, what is the input we have received, and what is the task ID, session IDs, model name. Session IDs doesn't matter, we will not be using that variable. What is important for us is a task ID. So session ID is basically to talk whenever you want to talk to LLM. If you want to maintain the session, so then you can use a session IDs. So session IDs will have a history, right? So to make sure that history is not wasted or something, we generate a session IDs. So right now for agent, session ID is not required. For agent's task ID is what important. Only for LLM you can give on a same session ID. So model name and communication types are present in this JSON. This will be passed in either delegate or P2P method or a direct method. So we have three different methods of communication from agents to agent: delegate method, P2P method, and direct submission to a directly talking to the agent itself, not by undergoing any other intermediate subsystems. So we have passed that job data itself along with the other details. So this is what the first agent will do. And similarly, if you go to I'll explain the agent COS now. So it has a multiple signatures. So as it has a multiple tasks to do, so like as soon as it receives an input, it has to ask for a budget estimation. Once budget estimation is done, then it will pass it on to the finance team to take approval, and if finance team approves it, then it will ask each agent to do a execution. Once those agents does the execution, they will provide the output to this particular chief of staff, and once the architecture is done, then it has to send again back to the testing team and the developer team. And when developer team is done, so it will talk to the testing team, and testing team, once it is done, it will pass on the output to the chief of staff. Then chief of staff, if all tests are fine, it will pass on to the CEO agent. So several communications are going within this particular architecture. So definitely the COS requires several signatures, DSP signatures. So like one is a execution trigger signature, and one is a artifact router signature, and a outcome summarization. Like finally it has to send the output to the CO, so that signature is present here. So every signature will have its own inputs and outputs. Let's say for this execution trigger signature, approval decision, like whether it is approved or not from the finance team, problem statement, and teams to trigger. So right now, like we have basically we require a team lead's information. So this is the subject ID of each team lead. So this is just the example, but this is not the final one. We just given an example, but this content will be basically generated using our other module known as known agent. So to identify who all are required by this COS agent, basically we require all the team leads. So we have module known as known agent, which will help us in querying the available agent in the DB. Let's say company team leads. If I say this word right, so while registering, let's say this is a CO agent, and we have something known as metadata. So in the metadata we have a search tag. So I have mentioned it as CO or a hierarchical demo kind of a tags I have given. But let me check one other agent, metadata. So you have a specialist, financial, something like that, some different names are there for one other agent. So with this, let's say if I search for specialist, I'll get a special this agent. If I search for a financial subordinate or something like that, I'll get a this agent, because I'm searching a search tag. That's what I have given in the my search query. So metadata.subject search tag is a company team lead. So this will basically pull all the agents who are a team lead in this particular company team lead pattern. So whenever you are registering these agents, right, testing team lead, developer team lead, I have to give a tag as a company hyphen team hyphen leads. That tag also I have to give in the registration. So then only those registers, those agents are pulled up. Those agents are searched or queried. And I'm just collecting their agent ID. So what is this agent ID? It is nothing but the subject ID. This company CO agent, which is a subject ID. So that's what we are trying to collect it here. So this is what all team leads are. And same pattern like whatever we saw in the previous agent CO, you have a cause agent class and you have a subject and context. It has initialized some variables. We have a task registry, which is a dictionary, which is a string, and again output can it's a value can be again a dictionary of any pattern. So then we have a his module, because as I told, his module is required to dump the output to the Streamlit app. So we have on data takes any time whenever it receives the input, be it from the CO or output of any other sub agents, it will come to the on data function. So in the on data function, we need to understand what it is, because we have several inputs is coming, right? So it could be an initiation task, or it could be a response to the budget estimation, or it could be the response of a architecture agent. So we don't know what type of input we have received. So basically we need to parse those the input that we have received. So task type is something that we are using here. So based on the task type, I will understand what this input is basically. So let's say when CO sends, right, so it is a initiate is a task type. When some other agents will send the output, it is a special report or specialized report, or some different key they will send the reports. So I'll open one so let me open this architecture team load. So by the time I'll explain this agent. So we have a task ID, we have to get a user request. It's a priority fallback if we have not got from the CEO. We are just trying to do a fast means basically a prototype. And basically based on the task, if task ID is not present in the task registry, I'm initializing that variable with all the details: priority, expected teams, budgets, team outcomes, all those variables, like the key values are initialized here to empty values. And then if there is a budget estimate in data, so then it's a budget estimation, so it will call one function. If it is a approval decision, so budget estimation is done and I have to collect it and I have to do an approve decision, then I'll call this function. Once let's say all the teams started giving their outputs, let's say marketing team has given the output, so I will see a team outcome in their data field. So I'll handle the outcomes of each team. So basically, since I have four teams, I should get output of 4 teams basically. So that's what I'll try to collect it and keep it. So if it is a task initialization, I'll call the first stage 1 broadcast function. So let us see what happens in the task stage 1 broadcast. So stage 1 broadcast, so I'll try to take all the teams from the all the team lead variable that I have initialized, but I don't want a financial team, because financial team is not required for the project execution. They just have to make a decision whether project is approved based on the finance or not. So I don't want to send anything to them right now, but I'll send to other teams. All the other teams except finance team will be expected in this broadcast message, where we are asking them to estimate the budget. So I got the expected team, and I updated the task registry for expected team results, and then I'm for each team in a loop, I'll send the input one by one. So estimate budget is a task type here, and it will be sent to each of the team in the send function. So send function might be in the bottom, which basically uses the again send function. If it is a delegate type or some other type, it will pass on this to the next agent. So whenever we are passing on to the next agent, right, so I'll just log it to the his dashboard. So in the his dashboard, whenever you will see the only 2. I have not logged the input. So you will see only the two, meaning whenever it is going from this particular agents, that only I am logging. So this is from the first function, the broadcast. So once the broadcast is done, they will, each individual team leads will estimate it and return the output. And once all the four teams, basically developer team, architecture team, marketing team, and testing team, estimate their budget and send back to this agent, so then it will come to the handle budget. So in the handle budget, what it does is it takes all the budget estimates present in the task.job data, because this is present in the budget estimate. Then it will be we're just updating our variables, registry variable. So each team, basically we have several teams, right? So each team, what is their estimate, so that value is present here, estimate.team name and estimate. So so if length of registry budgets is greater than length of expected teams, so we have 4 teams, that is what expected in the expected team, not a financial team. We have totally 5 teams. In that, finance team should not be part of a estimation budget. So if the these numbers are 4, right? So whenever we have received all the 4 budgets from all the 4 agents, because their output can come at any point of time, so I just have to have this loop and check. If not, we are just simply returning it. So whenever we got all the 4 budgets with us, then we are trying to send it to the company finance team lead for a budget approval. So approve budget is the task type. So company finance team will try to approve it, and if it is approved, again it will come to the COS for a for execution phase. So it triggers the execution phase based on the approval. So it checks whether approved is there or not. If approved is there, it will do it will go for the next. If it is not there, right, so it will say it's rejected. CO should negotiate. So that negotiation, again, demo escalate to CO. So that warning we are going, and we are returning back from this particular agent. So if budget is approved, we have approval status to true, and for each team it will try to pass on some tasks. So except finance team, I don't want to send anything to the finance team. So for all other agents, right, all other team leads, I'm trying to initialize a name for the team. What is this, what all those teams name, just it's a variable. So based on that, I will send those execute task as a task type, where they are responsible for executing their part of the work. So marketing will take care of marketing job, architecture will take care of architecture preparation, and developer will prepare codes required based on the architecture, and testing team will prepare a testing plan. So we are doing a send operation here based on the task. Based on this, these data are sent to the individual team leads. So once we sent, at the end, let's say all the one by one team leads will start responding their result. So then we need to handle the outcomes, so final outcomes. So basically, if there is an arc in the outcome.team name, and if there is a developer in outcome team name, so we are basically checking whether each and every it's basically routing here. So whenever an architecture is available, meaning we have got the architecture output, so then I need to pass on the this output of the architecture to these two, basically developer team and testing team. So that kind of routing, that's what the target is. And if it is a developer output, so developer has given the output, then I will pass that only to the testing team lead. So if not, then no, there is no targets here, so no downstream targets. So else, if it is not part of this, any of this testing, marketing, or financial, right, so I will do an inference here. So with the LLM context, with the chain of thought. So so I have the targets. I need to provide the target details and a router object here, where this router object is coming from a function. Sorry, yeah. So this is the chain of thought, and for this router object, we are just passing on some input. So this, with this signature, this router function will do a forward operation, which will basically use the LLM, and it will do an inference, and we'll get the output. So so this is how we do the routing operation. So target ID in targets, so we are just passing on the input. So this is required only when this agent has to take some decisions. So during that time only we are doing this. If not, it will be basically passed on to the targets. So whenever this agent wants to do something with their its signatures are provided above, it will do this, it will go to the else part. If it is not, if it has to talk to the other agents, then it will use this 3 loops. So here based on the target IDs, it will send the process artifact as a task type, and it will send to the individual agents. So, and also we are checking one variable whether outcomes, all the team outcomes, meaning every team has responded their final output or not. So if they have given the final output and it is equivalent to the expected teams, what is the expected team? We have 4 teams. One is testing team, algorithm team, sorry, architecture team, developer team, and marketing. If their the length of this team outcomes in the registry variable, and in the registry the expected teams, it is equal to or greater than, then it means all the result has come back to us from all the team leads. So let us finalize. So then finalize to CO function is called. In the finalize to CO, again we are trying to run an inference, because we have got output. It has to summarize all the output of a individual team leads, right? So we are passing on all the output of all the team names and total budget, and this summarizer will do a summarization operation based on this summarized signature, and that final report we will be sending back to company CO agent. And once that output come back to CO agent, it will, since it is a final project outcome is there, right? So this, because of this key, the CO agent will send it to the it will return back to the user. So this is how this COS agent is there. And if I want to show you some other team lead, so this is a team lead. This team lead also has a several signatures. So one is a estimation signature. So all the team leads will have this estimation signature, not individual sub agents. So only team leads will have a signature for budget estimation. So you can give a good example like how to estimate the budget. So if you have some examples, right, like for 1 hour of work, this much is the money. So that kind of examples you can give here. So that will give an how the LLM has to estimate, will give a good example for the LLM to estimate the budget. Right now I have not given that, so I just asked for team name and amount name and deliverables. So list of deliverables also I'm asking, because that deliverables is very important for us. Based on this deliverables from that team lead decides, that deliverables has to be passed on to the individual agents. So I'm asking it to generate the deliverables as well. So this is execution signature. So it's again for our team name. Deliverables will be given as a the problem statement and inputs from senior and junior architect. So since it is an architecture, so the output of a senior and junior architecture will be present here. So based on that, it has to do a team outcome, basically a summarization. So again, rest remains the same. It also has a known agent, his client. Rest remains pretty much same. To you will have some if and else conditions and like estimate budget, what needs to be done, execution task, what needs to be done, final blueprint sending, what we need to do. So this is where this is called when summarization is required. The final architecture summarization is required from the team lead, and then it sends to the COS. So this way we have several different functions for different tasks in individual agents. So I'll not explain all the agents code. So this is what the basic architecture. If you have seen our basic code, so if you have seen our other videos, you will you can understand this part as well. So let me go back to inference. So we can simply run this bash file which I have already run. So this will take care of unregistering, registering the agent, building the dockers, pushing the dockers to the repository, and deploying the agents, and also deploying the agents. So once agents are deployed, you can always check what all agents are present here. So let me just run this. So you have a executor pod. There are things that is needed by the AgentGrid SDK, and the pods that we have written codes for is running here. So in both this the architecture design team lead pod, the company architecture junior pod, and a senior agent pod. So you will see 2 by 2. Basically, we have 2 containers here. So they are, one is a Redis container, one is the actual code, and here is a 3. Again, they are this executors also will have 3 pods. Again, one is a Redis and 2 other containers are present in it. So if you try to, you can check the log of these agents as well, instead of checking the log, as it will be very cumbersome to copy and paste each and everything. So that's why we have used a his module to dump the output of those agents to the module, so that we can see it in a structure. So we can run an inference. In the inference, this is the input that I'm passing. Develop a task management dashboard Kanban style front end, a dashboard featuring a task board with columns for to do, in progress, done, and include forms for creating new project, and detailed task views, APIs to support CRUD operations for project tasks, user authentication, persistent and data storage. So this is the input from the user. Basically, this input goes to CEO. CEO will materialize, ask the COS to implement this particular project. So I will get the output like this, and I have just copy pasted it in my JSON formatter. So before going to JSON formatter, let me just show you this dashboard. So let me go to COO team. So COO team gets the input, and as soon as it gets the input, it will talk to the COS, chief of staff. So in the chief of staff, it will do an initiate task. It will give a product idea. It will give a whether it's in priorities, premium, what is the user original request. All those things are embedded here, and it will be passed on to the COS team. So here, important thing is, whatever is the bottommost message is there, right? That is the earlier message, I mean the old message. So whatever is the top, it is the recent message. So let me just go down to the bottommost page. So as soon as input is received by the COS, it will send a estimate budget for all the 4 teams, not the finance team. So we have a testing team estimate budget, we have a developer team estimate budget, we have a architecture design team estimate budget, and marketing estimate budget. Basically, it has broadcasted those message to 4 agent team leads. So once they send the their output, so it will collect all the outputs. Once all the outputs are collected from the budget estimates are collected, then it will send it to a finance team lead. So in the finance team lead, you see an approve budget task type, and it will give the details of all the agents. So team name, architecture design team is this much is the budget, marketing team is this much is the budget, and we have a different testing team, this much is the budget. So every team will provide their budgets. And also here, this agent is also adding some buffers, like some 3400 is added as a buffer, and it sums all the budgets of all the agents, and it has come to some 37,000, and this will be passed on to the finance team lead, where finance team will do a budget approval, whether it has to be approved or not. So if once budget is approved, it comes back to this agent saying that, hey, budget is approved. Then what this agent will do, it talks to testing team, developer team, architecture team, and marketing team to do a execution. Again, it does a broadcast, and those execution task type will be execute task is the task type that is sent from the this agent, so that those agent will start doing an execution. So once they are done with their execution, right, so all the agents will respond back. So here, developer team will respond back, testing team, because their job is to they will be doing now actual task. So let's say once architecture team responds, now that architecture has to be passed on to the testing team and developer team. So that's what right now it is doing. After a few, so after 12:58 we have sent the to execute the task, and at 12:59 we are sending from here, which is nothing but process artifact is what we are sending from testing to testing team and developer team. So within 1 minute, that architecture team also has generated the architecture, and we are sending it to testing team and developer team. So developer team, now it will take time to generate the codes required. At the same time, there is a marketing team also. It is executing in parallel. It will be doing all the content marketing strategies, whatever it is required. It will take care in parallel. So now we are passing on to developer team and testing team to take the architecture and do their work. And once they are ready, they'll come. The developer team will come back to the this team, the CO, chief of staff, and chief of staff says, "Oh, architecture, developer is also done with the code, and you can proceed forward to do testing." So as soon as a go ahead given from the chief of staff, the testing team will do the testing. So in this communication, right, so as soon as developer sends all the codes, so all the codes details will be presented here. Right now I have put all those codes in Minayo. So that's why we are getting a URL, but we can basically connect to GitHub or whatever it is. So all the JS files are here, front end and back end JS files are here, and all of the details are present here. What coming from front end, what coming from back end, all those details are present here. So with the help of those code, the testing team has to do a test. But right now we are not doing an actual testing, because the testing requires a simulation environment. Whatever the code we have generated, it has to be deployed and tested. For testing UI, you require separate packages, and UI testing is required. Like you take a mouse pointer, you have to click it, whether project creation happens or not. That kind of testing is required. That again deviates from our actual project demo. So we have not done those tasks right now. Test team will simply generates a test plan and says, hey, test is done. So at the end, this chief of staff will output the output. Once all the outputs are done, right, it summarizes and sends it back to the CO agent, and CO agent will send it back to the user. So that output is what we have. I have it in a JSON, which I'll explain later. So now let me go to some other agent. Let's say the marketing agent. Let me go to finance team, because as soon as the estimation budget is over, right, so it will come back to the finance team. So let me go to the bottommost. So finance team got the input right now, like all the inputs are in same timestamp. So it as soon as the team lead, always the leftmost is a team lead here. So as soon as team lead gets the input, it will ask for a balance check with the account agent, and account agent will respond with like what is the content we have. Like I'll just show you here. Check balance. Check balance is a task type, so it will asking it with the account agent. Account agent, as he maintains the book of records. So we have initialized the agent with some 70,000 as a number. So it says available budget is 70,000, and balance, this is the balancing report balance. It is a reporting for a balance. So it has reported back, and then since approval happens, the balance has come, and with that balance details, it will send to the controller, the finance controller and finance strategist. Hey, this is the budget estimate, and this is the balance we have from the account manager. You just give me a feedback. So that's what it will ask. Hey, it's a task type is validate. So estimate. So each team has given this much is the content, like how much they want, and we have a buffer as well, and we have a total of this much. Available budget is this much. So you give me a feedback. So that's what is asking. Now individual team will, based on their signatures, they will try to do a feedbacks. So here there is a financial strategist and company controller, controller. So they will send the output to a team lead, so finance team lead, and in that specialist output, output is a risk assessment, no overspending risk, it is realistic, and feedback to team lead. So the budget is within the available funds, is distributed reasonably, all teams are realistic. So that's what it will respond. So similarly, this team, the strategist also will respond. So cut amount feedback, some content has come from here, and please review the budget adjustment and proceed. So because I run 2 times, so that's why there is no budget right now, so that's why it is asking for a cutting a budget. So but in when you are running for the first time, since budget was there, it will directly come back here. So next, once both the outputs are received by the team lead will again talk to the it will talk to the account management, though like I have not sorted this within microseconds. So within seconds only it has sorted. So that's why what happens is this output supposed to go first. It will send this details to account agent. Hey, deduct the budget. So this is the project approval, so you just deduct the budget. So now that budget will go to the account agent. Account agent will try to deduct that amount, and now this is the available budget. And then at the end, this particular team lead will send the output to the chief of staff, saying that the project is approved, and it will collect all the feedback from this agent, and it will do an signature inference, and then based on that it will send the output to the COS. So this is what the finance team does. So once it comes back to finance team asks for an execution, because approval is done. Execute task is called, and let us go to the architecture team. So in the architecture team, okay, let me come back to the down. So first thing is a budget estimate, so it has given its budget estimate, and then a junior architecture, so it will send this information to junior architect. Hey, initial design, developer task management. So whatever the problem statement is there, it is giving it to the junior architect. Junior architect generates the architecture, it gives to the reviewer, who is a senior architect. Senior architect comes back with an critic. So it is basically ask some questions, critical questions. The proper architect lacks a proper indexing and query optimization in database. So that kind of critics is passed, and the junior agent again will process those critics, and again it will give the feedback. This way we have, like, I have controlled manually, like with up to 3 maximum back and forth communication had to happen. And at the end, the architecture design team lead will generate a final blueprint which will be sent to the chief of staff. And now the chief of staff will send it back to the the chief of staff will get this architectural detail, and then it will send it to the developer team and testing team. So in parallel, marketing team also doing a marketing marketing work. So here, first thing it received is a budget estimate, then it does the execution. It will send the execution task to each and every 4 agents, basically strategy agent, visual content generation agent, a planning agent, and a marketing content generation agent. So those agents will, on their own time, they will respond back with their output. Right now, the market visual agent, I'm using a Google Nano Banana to generate the images, not any other model. So it might take some time. It has to generate some 2 to 3 that also have restricted, like to generate a 3 images related to this particular product. So that become a marketing visualization, and these people also, these other agents also generating their own outputs. Like say, this is a team, this is the content generation agent, so it has generated some content. So empower your team. So this is the marketing content it has provided. And then we have a market planning agent. So when to plan, what to plan. So marketing planning details: channel, social media, SEO, content marketing, paid ads, timeline. Week 1, launch preparation and content creation. Week 2, social media ad campaign, paid advertising a week, and SEO optimization, content distribution, etc. So it's basically a planner for a marketing. And a strategist, so it will talk about focus on targeting professionals, students interested in project management and production productivity tools. Use the platforms like LinkedIn, Instagram to reach audience. So it has just generated a strategy for the marketing, and this will be sent to the team lead, and team lead will aggregate and send it back to the chief of staff. So here, right now, for all the communications, all the LLMs except this image generation, we have used a LLM that is hosted in AIOS, and that model is, so it is under this particular registration file. We can it's a VLLM type, and it's an the Quen 3 1.7b. It's a 1.7b billion parameter model, which is doing an inference with the help of VLLM library, and it is deployed in AIOS. So that's what it is, AIOS colon and the block name. We call in AIOS all the models that we have deployed as a block. So I'm giving a name like VLLM block. So it is a Quen 3 1.7b VLLM block, and these are the general parameters given, like some 10,000 odd token generations and some other parameters. So this is the model which is deployed. All the communications, all the generation, content generation, everything happens here, except the not just this marketing, every other agent. So even the code generation, everything is happening with that Quen 1.3 now, except the image generation. I'm using a Nano Banana. So now this is the marketing team. So architecture team, we have generated the architecture, then it gives the COS, sends it back to the developer team. Developer team also first is for budget estimation. Once budget estimation is done, it sends the task execution to front end and back end, and it will give all the details related to the architecture design, the architecture generated by the architecture team, and it will pass on to these individual agents. So these individual agents will generate the code responsible for the problem statement, like auth model.js from the backend, and the front end will generate their own files, and those details will be pushed to the Minio as well, and it will be given to the chief of staff. So this chief of staff, I can just open maybe one file. Yeah. So the chief of staff, the final output of a developer team goes to chief of staff. Chief of staff again sends it back to the testing team. So testing team here, first is the estimation budget, then it is an execution task. It gives all the source files of the code that is being generated by developer to the testing team. Testing team will generate like, hey, it is tested, all the scenarios are tested. So the scenarios are already generated by this testing team based on the architecture, and it has generated a test report. So that will be sent to the company testing team lead, and testing team lead will send it to the COS. At the end, COS will aggregate all the details and send it back to the CEO, and CEO will send it back to the user. So let me just take any other code. Database.js. Okay, so let's see. So now the final output, I'll just show you the aggregated summary of all the agents that we have, the output that we have received. So here, project outcome completed. Each and every team's details are present here. This team, what is the team name, architecture design team, what is the deliverables, status is completed, and this was the output of the architecture. It has designed a modular system architecture, front-end React with components for task board project scenario. So this is the content of the architecture team. And then marketing team, these are all the deliverables, and this deliverables was distributed again with the 4 different sub agents. So market content agent and market planning agent, so it will plan about when to do, what to do in the next few weeks. And then strategy, so basically what all social media platforms to use, how, what all individuals or students to pick, I mean people to pick to for marketing, all this defined by the strategist. Then visual content, so the images generation, it is doing an image generation. So let me just show you this image. Okay, it has generated some images related to the Kanban. Okay, so it has generated some Kanban images based on some query that we have written. It is maybe create a new project kind of a doc. Maybe if you have more images are required, we can just tune that file, the marketing file. So this file is not loading. Those files are present, but it's not loading. That's fine. So so next is image generation prompts are also present here. What prompts it has used to generate the images. Then developer team lead. So these were the deliverables. Status is success. Repo summary. So what all files are present, and individual files details are present here, and those files URLs are also present here. So why it's not opening? Let's see. So next, individual files, the front-end developer contents, the files are also present here. And then team name, testing team, so what all are deliverables and what all testing scenarios it has covered. Validation, all scenarios are valid, covered for functionality. So basically it has also given the result of the testing team, and at the end total budget spent. So this is the output of the final outcome coming out of a COS to CEO and CEO to the user request. So this is what the hierarchical agents demo is, where a complex business task will be subdivided into several other teams, and the teams again subdivides the task into sub agents who are responsible for doing some specific task. Right now we have used only one LLM, but let's say imagine we have a specific LLMs, let's say a marketing LLM which is specifically trained or tuned for marketing content generation, that would do a better job, as this is a general LLM. So we can always think of subdividing the task with respect to their own their own metadata in the training, or their own knowledge while training. So by dividing the task to a sub agent, so they will, as they are specialized to that particular problem statement, so they will do a better output. So basically in current hierarchical pattern, complex business process that required a multi-round coordination, financial oversight, and sequential task dependencies. So wherever the task dependencies were there, that was also resolved. By mimicking a corporate structure, you can build a scalable multi-agent system that handle end-to-end product development workflow. So this is just one example as a for explain the hierarchical pattern we have. And you can always think about several examples. Let's say video generation. You know that all the LLMs can generate a small videos, but you have one big story maybe you can use several sub agents, like say video generation, image generation, because generally sometime you want to do generation of a video from image to video, so then image generation is required. So image generation agent, content generation, voice generation. So you can have several teams which will coordinate themselves to create their output, their part of output, and at the end it has to be clubbed by one other agent, for who is the master agent, who is monitoring and coordinating between all the sub agents. So that way you can implement. So this is the example of a hierarchical agent using our open source AgentGrid SDK. So with this I'll try to finish this video, and also just stay tuned, because I'll in the next video I'll show how to use other concept like DSL workflow concepts, how to improve these agents. Right now everything is pretty much in the code, so how to create a workflow out of it. So stay tuned for that particular video. So thanks for watching. Keep supporting us. Thank you.